The modern fragrance industry is a multi-billion-dollar empire built on absolute precision. Every bottle on the shelf is the result of highly engineered chemistry. While we associate this level of luxury with modern Europe, the scientific foundation for these scents began over 1,200 years ago in the Middle East. Before the 8th century, perfume making was a messy, inefficient craft. To capture a scent, artisans had to process mountains of rose petals, crushing them by hand and soaking them in base oils. For larger batches, they harvested entire fields of aromatics like lavender, relying on sheer volume to extract even a baseline fragrance through simple steeping. These methods had severe chemical limitations. The raw botanicals remained in the oil, leaving the final product full of organic mud. This caused the scents to degrade rapidly and lack any real purity. This also made consistency impossible. Because the process relied on hand crushing and soaking, a perfumer could never guarantee that one batch of jasmine would smell exactly like the next. Traditional perfume making was restricted by its crude tools. Without a way to separate individual molecules from the plant mass, the true fragrance remained inseparable from the decaying organic matter. Jabir ibn Hayyan believed that rigorous chemical experimentation, rather than artisanal tradition, would finally isolate a plant's true aromatic essence. He turned his attention to distillation, the process of using heat to separate the components of a liquid, and perfected the technique for aromatic oils. He achieved this through specialized hardware, the alembic. Applying controlled heat to botanicals in the lower chambers allowed aromatic vapors to rise without burning. Traveling through the curved necks, vapors cooled, condensing into purified liquid essence at the spigots. By forcing the botanicals through this liquid-to-vapor transition, Jabir successfully stripped away the physical plant matter, isolating the pure aromatic molecules for the first time. The hardware was only the first step. Jabir's true breakthrough was his insistence on scientific variables within his laboratory space. He systematically recorded the results of different temperatures and heating times across hundreds of different botanical experiments. This data revealed that microscopic heat adjustments produced vastly different fragrance profiles from the same raw material. Documenting these metrics, Jabir created mathematical formulas for fragrance. For the first time, a scent could be reproduced with perfect accuracy. This precision allowed for the successful extraction of incredibly delicate oils, like jasmine and sandalwood, without destroying their complex chemical structures. By applying mathematics and controlled variables to aromatics, Jabir successfully transformed perfume making into a reliable, reproducible science. Physicians quickly noticed that Jabir's purified botanical extracts possessed potent medicinal properties. They adapted his distillation process to isolate active medicinal compounds from plants that were otherwise too bulky or toxic to use in their raw form. This alembic technology eventually scaled up, moving beyond biology to improve broader chemical engineering processes across many different industries. Jabir's initial search for a better perfume provided the foundational extraction and purification techniques used in modern pharmacy and chemistry. Today, the multi-billion-dollar fragrance industry operates in pristine, high-tech laboratory environments. Despite our advanced technology, these laboratories still rely on the same fundamental principles of distillation and purification that Jabir perfected over 1,000 years ago. Every spray of a fine fragrance is a direct link to Jabir ibn Hayyan's laboratory. His methods did more than capture a scent. They established the standards for purification that still define chemical research today.